Good morning everyone, I am Aastha. Today I will be presenting on the topic Hadoop, its architecture, components and real world use cases. Hadoop is one of the most important technologies in the field of big data, and by the end of this session we will be clearly understanding how it works and why it's so widely used. Let's start with the basics. Big data refers to extremely large data sets that are beyond the capacity of traditional databases to store, manage, or process efficiently. To understand it better, we use the 5 V's: volume, velocity, variety, veracity, and value. Volume, massive amount of data being generated. Velocity is how fast the data is produced and processed. Variety is different types of data, that may be text, image, videos, logs, etc. Veracity may be uncertainty and quality of data. Value be the meaningful insights we extract. These 5 V's are exactly why organizations require new technologies like Hadoop. Now we see what is Hadoop. Hadoop emerged as a game changer in the world of big data. It is an open source framework developed by Apache to store and process huge datasets efficiently. Earlier, organizations struggled with the three main issues. Data first, data was growing too fast. Second, traditional systems were expensive. And third, processing large data was slow. Hadoop solved all these challenges through distributed storage and parallel processing. Now we see what is Hadoop and why do we need Hadoop. So what exactly is Hadoop? It is a framework that uses cluster of commodity hardware to store and process massive amount of data. Hadoop is chosen because it's scalable, it's cost effective, it's fault tolerant, it can handle any type of data. This made Hadoop the foundation of big data analytics for many years. Now why Hadoop? Because Hadoop handles petabytes of data efficiently across distributed systems, runs on commodity hardware, and significantly reducing infrastructure cost. Built in fault tolerance automatically handles hardware failures. Now we see Hadoop ecosystem, complete big data stack. Hadoop is not a single tool, it's an entire ecosystem. It includes HDFS for storage, Yarn for resource management, MapReduce for processing, along with high level tools like Hive, Pig, HBase, Scoop, Flume, Zuckerper, Uzi, and many more. Together, these form a complete end to end big data stack. HDFS, Scalable and Fault Tolerant Storage. HDFS stands for Hadoop Distributed File System. It is designed to store very large files across multiple machines in a cluster. Key features including scalability, store petabyte of data, fault tolerance, data is automatically replicated, high throughput, optimized for large data sets, cost effective, uses commodity hardware. This makes HDFS the backbone of Hadoop. HDFS architecture deep dive. This slide explains HDFS internally works. How HDFS internally works. It has two main components, name node and data node. The master stores name node is the master that stores metadata, manages the file system. Data node, the workers store actual data blocks. When you upload a file, it is split into blocks, replicated and distributed across data nodes. Even if a node fails, HDFS recovers data from replicas. That's how fault tolerant is achieved. Yarn, resource management. Yarn stands for yet another resource negotiator. While HDFS stores data, Yarn manages system resources and schedules tasks. It has two major components: resource manager that decides how resources are allocated, and node manager that monitors and manages each node. Yarn ensures that all jobs running in the cluster get proper resources without conflict. MapReduce, that is distributed processing. MapReduce is Hadoop's original data processing model. It processes data in two phases, map phase and reduce phase. Map phase is processes and filters input into key value pairs, and reduce phase aggregates and summarizes the output. Parallel processing is its biggest strength. A classic example is the word count problem. The map phase counts occurrences of words and reduce combines the counts. MapReduce data flow. This slide shows the complete life cycle of a MapReduce program: input, mapper, shuffle and sort, reducer, and final output. The shuffle phase is critical because it groups data based on keys. This entire workflow runs across multiple machines simultaneously, making it highly efficient for large data sets. Ecosystem tools and technologies. Hadoop's ecosystem expands through many powerful tools: Hive SQL for SQL like querying, Pig for data transformation scripts, HBase, NoSQL database, SQube imports exports data between Hadoop and RDBMS, Flume collects and sends log data, Zookeeper coordination service. This ecosystem enables Hadoop to support storage, processing data, movement, analytics, and coordination. Hadoop versus traditional systems. Traditional systems scale vertically by upgrading the system machine. Hadoop scales horizontally by adding more inexpensive machines. Compared to traditional systems, Hadoop is cheaper, more scalable, and more fault tolerant, capable of processing unstructured data. This is why Hadoop quickly became the preferred choice for large scale data workloads. Three-layer architecture summary. Hadoop's entire workflow can be summarized into three layers: storage layer, HDFS, processing layer, MapReduce, resource management layer, YARN. These layers work together seamlessly to handle big data from end to end. Real world applications. Hadoop is used across almost every sector: finance for fraud detection, e-commerce for product recommendations, healthcare for patient analytics, telecom for network monitoring, social media for user behavior analysis. Industry leaders using Hadoop. Many global companies rely on Hadoop for data processing. Some major names include Facebook, Amazon, Netflix, Spotify, LinkedIn, and Yahoo. Key advantages of Hadoop. To conclude the technical part, these are the major advantages of Hadoop: cost effective storage, highly scalable architecture, fault tolerance through replication, handles all data types, open source, and widely adopted. These trends made Hadoop the foundation of the big data era. Thank you so much.